Hello, Mohit ji.
Yes,
Sir, may I request you to share the screen?
yes.
Share the screen first.
Is it visible to everyone?
Yes,
Yes, sir.
yes.
Sir, would request you to make it in the presentation mode.
So can we start?
समझ रही हो
Yeah.
या मुझे भी पता है हरकत कैसा है, तो हमें थोड़ी बुरा तो लगता नहीं है। हंसी आती है उल्टा।
Okay, so good afternoon, everyone. Am I audible?
Good afternoon, ma'am. Yes.
Yeah. Hello, sir. In the time request, I request everyone to please mute your microphones. And we can have the question and answer at the end of the session. So during the presentation, I request all of you to please put your microphone on muted mode. So welcome to you all. This is a webinar entitled Basic Safety Criteria for Safe Operations in Slab Stock PU Foam Manufacturing, an insurance expert's perspective. And this will be delivered by Mr. Mohit Darbari from AON. And I'll just briefly introduce Mr. Darbari. Education-wise, he is an engineering graduate in industrial and production engineering. He holds a PG diploma in fire protection and safety from MIT Pune and also an MBA from Assam Downtown University in the same discipline. He has 14 plus years of experience of working across manufacturing units, including pharmaceutical and chemical and private sector insurer companies. In his span of 14 years of work he has worked across risk management, safety audits, risk analysis, and loss control also. Having experience of 14 years in variety of industries like chemical industry, pharmaceutical, power plants, automobile industry, energy, refinery, and petrochemical sector. At present, he is associated as an assistant vice president with AON. We welcome Mr. Darbari. You can start your presentation now.
Thank you so much, ma'am, for the brief introduction, and good afternoon, everyone, for joining this particular session. Thanks, Indian Polyurethane Association, also for arranging this particular webinar. The topic of today is basically the basic environment, health, and safety criteria for safe operations in a slab stock factory and insurance perspective. So, going to the next slide. So the agenda of today's webinar would be about the introduction about the foam industry, then the risk analysis point of view, risk management, insurance perspective, and how you can transfer your risk to an insurance company. So the agenda would be briefly divided into 3 or 4 categories. I would like to explain. So first of all, we will be talking about the importance of risk assessment in the factory for the hazard identification and risk mitigations. The second part is this, how we can transfer our risk to an insurance company by paying a considerable amount which is known as a premium, so that our risk can be insured by an insurance company, and how this particular industry, the foam industry, is different from the other industrial units which are working in your nearby region or nearby areas, right? So this is the whole agenda today. We will be only talking about the fire insurance today because of the constraint of the time. Insurance is very vast subject. So today we will be only talking about the industry insurance, or you can say the fire insurance. Right. Whatever questions you are having, it is requested that you please note down of your all of your questions. And once we will be completing our presentation, you can ask one by one to me. You can either unmute yourself or you can use the chat box option to ask a question, right? So thank you so much for your understanding. So going ahead, my name is Mohit Darbari. I represent Aon India Insurance Broking. I am from Noida office. Today I am sitting in the same office. Aon is a multinational insurance consultancy company. We are having more than 60,000 colleagues around the world. We are having the presence in more than 120 plus countries. In India, we are having the offices in 6 locations covering all the metro cities. And we are having more than 500 employees. We deal with property insurance, health insurance, fire insurance, marine insurance, and reinsurance. So every type of insurance consultancy is being done by us. So this is about Aon, short and crisp. Going ahead, um, the first slide is about the foam industry and introduction. Uh, I would say I'm not much qualified and to know about the process and all. The the you all who have joined this particular session are basically into this industry for a longer period of the time, and you know the process, you know everything more than me. But just to refresh our knowledge in terms of how it works, I have just made one particular slide about the introduction. So it is easy. I'm not going to read the entire slide. So uh, main two chemicals, polyol and isocyanate. When we do some chemical reaction of all these both of these chemicals, we got the PU foam. The important in this particular slide is the first paragraph, as you can see here. The polyurethane foam is the commodity from the plastic family group, classified as a uncartoned expanded plastic UEP as per NFPA 13 and FM Global Data Sheet 8 or 9. So what is NFPA? NFPA denotes for National Fire Protection Association and FM Global Data Sheet. So these they both are the entities who basically deals in terms of the fire prevention or fire risk reduction methodology. So they have standard for different occupancy for different commodity. So this particular commodity which is mentioned here, uncartooned expanded plastic, this will be useful when we go into the further slides. Then I will be talking more about this. Right now, just for your reference, you please note that the polyurethane foam is the commodity from the plastic family group and which is classified as a UAP, right? Process point of view, I think everybody is aware that the mixing, foaming, and the curing are the main process for manufacturing of foam. However, the further processing is being done for reducing the thickness and as per the business and the customer requirement. So we all know it's a customer-based industry. So everybody do customization according to the requirement of the customer. The main, can you please mute yourself? The manufacturing of the PU foam is an ex.
हेलो
Hello.
कुछ भैया थोड़ा मैं मीटिंग हूँ अभी थोड़ी देर में बात करूंगा
Hello.
Yes, sir. I have muted all the participants.
Okay. So manufacturing PU foam is an exothermic reaction with a very high heat release rates. This is one of the main process fire hazards, I would say. The reason is this: when we talk about the reactions exothermic and endothermic, these two type of reactions, if we go to the basic chemistry times, so exothermic reaction and endothermic reaction, what is the difference between both of them? The exothermic reaction, when it is happening, then this release the high heat, and endothermic reaction is basically absorb the high heat. So this is the basic reaction, basic difference between both of them. Manufacturing PU foam is an exothermic reaction, and when the temperature goes beyond 160 degrees Celsius, there is a chances of auto ignition. I'm sure that you all must be aware about this particular process, right? So chemical reaction majorly exothermic using barrier catalyst for increasing or decreasing the reaction time. This is just about the introduction, how we manufacturing the foam. Then depend upon the quality of foam which you are manufacturing, maybe the quantity of and the requirement of catalyst, the reaction increasing or decreasing time may go vary according to your finished product. The right side is just a diagram shown that how the polyol and isocyanate is basically being transferred from your tankers to the tanks area. So in the bigger industry, I have seen that it is coming from the truck and using the flexible pipe, it is being transported to the fixed sort of silos which are made in the separate compartments, separate areas. And in terms of like small and medium enterprises, which are comparatively smaller than the bigger industries, they may be using some tanks, the MS tanks or some different type of tanks or horizontal tanks, barrels for storing of these chemicals. So this picture is just shown, and before above of that, the chemical reactions is basically shown how the polyol and isocyanate being mixed with each other, and the chemical reaction takes place, and we get the final product as a PU4. So this is just an introduction how we got the polyurethane foam in terms of getting two raw materials, which is polyol and isocyanate, right? Now going ahead, when I did the risk analysis of this particular industry, I came to know that the the, the principal hazards in these industry is the obvious one. That means the hazard in this particular industry as compared to other industries are little bit onto the higher side because of the occupancy itself, because of the process, because of the presence of combustible material, or I would say the flammable material at each and every stages. Raw material is also combustible, the finished product is also combustible, and the process is also I would say it is little bit onto the hazardous process, right? So
Sir,
by
PPT
saying,
is not visible.
sorry,
PPT is not visible.
is it not visible to one person or nobody can see this?
Sir, we
It
can
is
see that.
visible. It is visible.
It's visible.
See-
Okay. So I'm saying that the fire load in this particular industry is little bit onto the higher side. So by saying that it is onto the higher side, that doesn't mean that other industries are not having such type of fire load. But when I compare this industry like with some industries who are dealing with the non-combustible material, like for example, if you can see any industry who are making utensils, right? So for making utensils or for making TMT parts, the raw material would be like mild steel coils, mild steel plates, and the finished product would also be non-combustible. So your raw material is also of metal, your finished good is also of metal, and the process is not that hazardous, you know. So in comparison to those type of industries, the foam industry is the uh, a little bit onto the higher fire load, right? I have just do the analysis by having this ignitability of material and heat releases, which is self-explanatory. You can see here. The polyurethane foam flash point is also to the higher side, the ignition point and the oxygen index into the higher side. Practically, in some of the case studies where I was involved in, where the fire incident took place, I have seen that in case of the fire happened in the foam, it is it is not burning, you know. It is not even converted into thick black smoke uh, or I would say a flame. So it is more like a smoldering fire, like a cotton fire. So that means it is more hazardous because we cannot identify the originating point where the fire has been started, and accordingly we cannot extinguish also. Right. So this is how the risk analysis is being done of this industry. Now
Yes.
uh, going forward, we have just bifurcated the, the hazard into four categories. The first is the storage of raw material, then manufacturing process, then finished goods and other fire hazards. So the PU foam industry in any industries where I did the inspections, I'm a risk engineer basically. So we usually categorize the hazards into four categories, starting from raw material, then the process hazards, then finished goods, and what are the other fire hazards. So similarly, I have done it for the PU foam industry also, which falls into four categories. Now, when I'm going to the storage of raw material, some of the hazards which you can see in your screen right now, there is a risk of sliding and rolling of drums. So drums, when I'm saying, it is a chemical drums, a risk of pressurized drums of TDI, try uh, uh, this isocyanate, risk of chemical tanks collapse, over pressurization can happen, spillage and leakage can occur, overfilling of the tanks, runaway chemical reaction induced by the water, and apart from that, all the three chemicals or the two main chemicals which we are using, the polyol is non-flammable, but isocyanate is little bit dangerous. It is a flammable chemical. And I think the occupants who joined the webinar, basically from the mattresses industry or the seats manufacturer, they use acetone also sometimes. I have seen for the cleaning purpose, right? So acetone is highly flammable, whose flash point is somewhere around -20 or -22 degrees Celsius, right? So these type of risks which are associated with the raw material storage when we store the raw material in our facility. Now, going forward to the next slide, the specific hazard in the process, when we convert the raw material into the process, then I had already discussed that when the temperature can rise above 180 or 160 degrees over foaming process, leading to the self-ignition posing the fire hazard. So this is a very, very critical point in any puff industry, that you have to be a very, very careful about the temperature. So when the temperature is rising above 160 degrees Celsius, then there is more chances of having the self-ignition, or I would say the auto-ignition in that time. Decomposition reaction undergo by polyurethane can result in the formation of carbon monoxide. The third point I'm talking about. So carbon monoxide is not a very, very flammable gas, I would say, but it is very much hazardous for the human being. So if we inhale more than a quantity of the carbon monoxide gas through our breathing process, then there is a chances that we can go unconscious, or even the person can have the more hazard by inhaling the carbon monoxide. So this is one of the major hazard of the process. Probability of auto ignition combustion in the long block. So the finished good we are getting after the foaming process is either into the short, small block or a long block. I have seen in some various case studies also previously where the auto ignition occurred into the long block because of the size of the finished product. Polyurethane foam known for very high heat release because of the extremely toxic fumes. So what happened is, I'm talking about the second point here. So when any fire happened in the polyurethane foam, heat release is absolutely high. So when the temperature would be high, then anybody who are going close for extinguishing the fire, it would be very difficult for him to manually extinguish the fire. And apart from that, if you are not having adequate breathing apparatus or what I can say personal protective equipment, which is known as PPE, then it is you may be troubling yourself by extinguishing the fire at that particular time because of the toxic fumes, right? Polyurethane, if powdered into the fine dust, can generate dust explosion. The fourth point. This is the another hazard which I have seen. So for happening the fire, only three things need to be present. No, fire triangle: oxygen, heat, and fuel. But when it is converted into dust form, so dust can also explode. Polyurethane dust, if it is converted into the powder form, so we have to very, very careful uh, when we are doing the finishing of our long block or a small block, then some residue or some wastage I have seen in some of the industry shop floor area, which is normally there, and after certain hours it is being accumulated by the housekeeping person. But in the ideal situation, it should be at the moment it should be done, and it should be accumulated into some different segregated area, not in the storage or your shop floor area. The reason is this dust can be extremely dangerous, and as we can see in the number fourth of the point. The forming machine are enclosed in many cases and can be the obstruction to sprinkler protection. So in some of the factories where the sprinklers are installed, so the foaming machine, as you can see, that is totally in the closed loop, entirely closed loop. So sometimes what happened is the sprinkler which are installed in the ceiling are not able to extinguish the fire if happened inside the foaming machine because of the obstruction. So this is some of the hazards pertaining to the process of the uh, puff panels. I'm really sorry, my throat is not good today. I'm a little bit cold, so my voice may be a little bit out the higher side. Please pardon me. So this is some of the process specific hazards. Now going into the finished goods. Finished goods is usually in the form of long block, small block, PU foam sheet or mattresses, etc. So as we already discussed, probability of auto ignition in the long block storage area, which is one of the risk if we are not uh, if we are not judging the temperature into each and every stage, then we are just creating maybe the risk. We are not minimizing the risk properly in that situation. So for risk mitigation, that measuring the temperature also, especially in the long block storage area, is a critical factor. Difficult to extinguish the fire if it is happens. This is a very, very important point. So in some of the industries where I have seen that if you install the fire extinguisher, if you install the fire hydrant system, manual firefighting system I'm talking about, and in case of the fire happen in these in or in those industries, maybe you can use the fire extinguisher and douse the fire by going there. But in this particular industry, it is very difficult to extinguish the fire because it is very difficult to identify the originating point of the fire at the very, very initial stage. If you are able to find out the originating point, then it is okay. But if you are not able to find out the originating point after 1 minute or 2 minutes, you cannot find out, and from the smoldering side, it can go to any direction. Rapidly, ignition can happen. So it is difficult to extinguish the fire if it is happens. Wind is often a serious factor. So why wind is being mentioned here? So wind direction is also a very, very serious factor. So if the wind direction is from one direction to another
Oh,
direction, hello,
oh भाई
can you please mute yourself?
इसको बंद कर दूं?
Rigid polyurethane and polyiso foam, when ignited, burn rapidly and produce intense heat, dense smoke and gases which are irritating, flammable and or toxic. So this is the another challenge. So when there is a fire, what we are getting is basically the thick black smoke. So we cannot see anything. What is there? So it is always better that in this situation, we should evacuate ourselves to the nearest emergency assembly point, which is made inside your facility, and do not do the firefighting. If the trained firefighters are present in your facility, let them go inside and do the firefighting work along with the adequate personal PPEs, personal protective equipment that they are having. The last point is curing process is a stage where the continued chemical reactions occur, completing the desired characteristic of the product. So this is a very, very important stage. What we have seen, a lot of incident we have witnessed in the curing stage. When the foaming is already completed, the product was just stored in the curing zone for 24 to 72 hours, and there is no electrical installation, no source of ignition is there, nothing is there. Still, the fire was happened in the curing process just because of the chemical reactions and auto ignition, as we have already discussed. So this is basically your commodity inherent property if I'm talking about. So whether it is your finished product or your process fire hazard or your raw material, this is the inherent property of the foam that these type of risk, these type of hazards are being present. Now, next topic is how to mitigate those hazards, how to minimize those hazards. So one idea is basically, so before that we will be talking about other hazards also. So other hazards, if you are talking about in any industry, unsafe electrical condition. So in the puff industries, if I'm especially talking about, you have to be a very careful for your electrical condition. No do's, no naked, no bared wiring is allowed in any part of your factory, whether it is a process area, whether it is a raw material storage area, whether it is a finished good area, whether it is a scrap area, whether maintenance workshop, any areas, admin building, no electrical unsafe condition should be there. So it is always suggested from our side, from insurance perspective, that all the electrical installation should be industrial type. And wherever you are having the flammable solvent, flammable chemical storage, flammable uh, uh, combustible chemical storage, please go ahead with flame-proof electrical fittings. No industrial type, no domestic type switch should be allowed. The second is hot work cutting and welding. So it is an important thing, cutting and welding. So if any operation is happening or any operation need to be done within the facility, within the production block, it is always suggested that you should first isolate the storage area with that area of hot work so that no spark can go to your storage area or your production area, which can convert it into the fire. The third is electrical sparks, then frictional heat, lightning, spontaneous combustion, smoking. Smoking should not be allowed in the puff industry. Uh, Even not inside the factory, it is not recommended even in the smoking zone also. So in the another factories where I have seen who are basically engineering industries, as we discussed, they usually make one smoking zone near to their reception area or near to the security room, but it is absolutely not allowed in the puff industries. So no smoking should be done. Natural calamities is one of the issues which is not in humans' hand. So when we are talking about natural calamities, it is like earthquake, wind, flood, right? Fire and explosion from the neighboring industries. You have to be very careful. What is your neighbor's manufacturers? So suppose if our factory is safe, we have installed sufficient amount of the safety management system, fire protection system, but our neighboring industries are not having good distance from my industry, and they are not having any fire protection or detection system. So any fire, if happen from their premises, can come to us also. So a little bit careful about what our neighbors are doing. We have to be uh, careful about that aspect also. The the tenth is arson or mob attacks. This is again the thing which is not in our hands, but this is the hazards which are present. Aircraft damage. So if your facility is located near to airport or into the zone of where the landing of the flight is happening or a takeoff of the flight is happening, then one of the hazards are there of aircraft also. Then waste storage within the production area. This is one of the most important thing and the critical, I would say, especially to the puff industry. I have seen it where the occupants are storing the waste near to your storage area or the production area. So when we are storing the waste, we are just increasing the chances, the hazards we are increasing just because of the storage of the waste product. So in case of any fire originating in the waste storage area, it can easily go to my storage area or a production area. So it is always suggested, always recommended that the entire waste storage area you should make a separate compartment or a separate structure which should have RCC, and you should have adequate distance. So when I say adequate distance, it should be like 15 or 20 meters away from your main building where your main operation is happening, right? The foaming operation, the storage of your final product is happening. So there you can storage the entire waste, and no electrical installation is allowed inside the waste storage area. So this is all we are talking about the other hazards. Now going to risk management point of view, how we can control the risk reduction and loss prevention methods, right? So the first is we can store the polyol and isocyanate into well-contained retention basin areas. So when I say retention basin areas, that means that if you are storing tank, if you are having the metal tank, should not store directly over the ground. So once you store directly over the ground, maybe some spillage or leakage you could not identify. So, and if you are having made the tanks or silos, then one dike should be provided so that in case of leakage also, if happens in those uh, uh, main tank, it should not be accumulate. It would be accumulated into that dike only. That chemical will not spill out from that areas. So this is the some of the risk reduction measures pertaining to the storage of polyol and isocyanate. Offloading of the truck into the tank should be organized in the way to remove any risk of human error. So when we are doing the connection of the pipe from tanker uh, to our tanks, basically, so we should be very careful so that polyol should be connected to the polyol and isocyanate should be connected to isocyanate. And the same similar would be for the other chemicals also if you are using in your industry. We should make some SOP for different color coding of different pipeline for isocyanate and polyol means polyol should have different color coding of the pipeline in the entire factory. And if you have followed the yellow color pipeline, suppose if you follow the yellow color pipeline for the polyol, then the entire polyol pipeline in your entire factory should have the yellow color, right? It should not be like after certain meters or after certain kilometers it has been converted to some other color. It is not recommended. So different colors should be used for both the chemicals, and you should have the pipeline color coding in your factory so that anybody who are coming from the outside for the auditing for the assessment purpose, they can easily identify from your main entrance gate only that okay, this is the polyol pipeline because the color coding of the polyol is yellow or green or whatsoever, right? So this is, and this document should be made by the plant management. Good housekeeping in the curing area, no stacking more than 3 levels, use of crane to lift up blocks, a well ventilated place for the curing. We already discussed that curing is a little bit more hazardous in comparison to even process because of the auto ignition probability. So the thumb rule is this: the stacking should not be more than of 3 labels. So maximum you can store up to 3 labels. Housekeeping extremely you have to be very careful for maintaining the housekeeping in the curing area. It is always better that the crane should lift the blocks because it is also not possible for human being to lift the blocks. It is very huge in size, and well ventilated places for curing means there should in case of any smoke generation or anything it should be, if the ventilation should be there, it would be automatically going outside, right? So this is the fourth point. Tanks of polyol and isocyanate should be in the different retention bunds, and any collection point should not meet. Any drainage point should be pumped out. Ideally, storage should be in the covered area. So the meaning of the fifth point is this: that uh, in any case, these two chemicals should not meet with each other during the time of loading or unloading from the tanker to a tanks, right? So the chemical reaction which is being required for converting the same into the polyurethane foam, that will be done in the foaming process itself. But before that, these two chemicals should be stored in the isolated places and should not meet with each other. So for that, the different safety practices, the documentation, the SOP, whatever is required, that you have to meet basically, right? The sixth point is, sorry, monitoring of the blocks in the curing process should have direct reading the block's temperature using probes. We already discussed this point. As I already said, the long blocks temperature monitoring is very critical for hazard minimization, risk minimization, right? So we are using probes to read the block's temperature into different areas. Tracking of temperature profile will identify the blocks with a hazardous reaction and trigger the rejection of the blocks to the end of the transporter on the exterior away from the building. So when we do the temperature monitoring, so what it will be give it, first of all, it will give me the idea that everything is okay or not. The first of all, the second is this: okay, whether the temperature, if the temperature is high into the one end and the very low into the another end, that means it is a little bit problematic for us. So you can just using the crane and transport the blocks from that area to the safer area, exterior away from the building. So this is the benefit of measuring the temperature using probes. Start, end, and immediate blocks must be stored and monitored in the safe way. The fire-resistant compartmentation or additional fire protection. The blocks to be stored in a way free space of 5 centimeters is maintained between each block. This can also vary based on peculiar manufacturing safety experience. Uh, the most important point from the insurance when we visited any industry. So when we normally see that how spread it is, how big it is, what is the what is the distance between each and every building. So if you are having the foaming building as a separate building, if you are having the raw material building as a separate building, if you are having the curing building as a separate building, if you are having the uh, admin building as a separate building, and you are having the good distance among all the buildings. So it is a basically I would consider as a good factory from my point of view. The reason is this: in case of any one building got fire, the other buildings would be safe in that point of view. But I can understand that is basically design to design point of view. But if you are not having the place, if the space constraint are there, something is there. So for minimizing the risk, you can have the passive fire protection system or the fire resistance compartmentation. So you can just make the brick wall between two compartments so that I can just isolate the curing area from my raw material storage area or my finished goods storage, sorry, for my foaming area. So that particular wall would give me additional support of like 1 hour or 2 hours of fire resistivity. So this is how small steps we can take for minimizing the risk. The last point is the provisional of spark arrestor in all diesel and petrol vehicles and material handling equipment. So if you are using the diesel and petrol vehicles for for moving your raw material or barrels or your home, anything else, you please first of all, it is always recommended that please change the same into the battery operated forklifts, and if it is not possible, then please use the spark arrestor in your in your all the forklifts and all the material handling equipment. So these are some of the risk reduction measures which I'm talking about here. There's a vast list. So when we usually visit the factory, then from that point of view, some of the practical things also come up. But these are some of the thumb rule, I would say, which should be applicable to all the top manufacturers and the allied product industry. Now going ahead, uh, other risk reduction loss prevention measures is basically the fire detection protection system. So you should have fire extinguishers, hydrant system, water monitors, beam detection system, ESFR sprinklers. Then in the passive fire protection system, fire resistant doors, fire retardant paint over electrical cables, sealants, emergency exits, emergency lights. These are some of the basic loss preventions measures which I have highlighted in this particular slide. The most important in this is basically the ESFR sprinkler. As we already discussed, that manual firefighting in puff industries is very difficult. So in case of the fire, if happened in this type of factory, using fire extinguisher, using fire hydrant system is extremely challenging for dousing the fire. We have seen in our peers industries also where ESFR early suppression fast response sprinklers have the great feasibility for dousing the fire. I have just having one video also I'll be showing you after at the end of the presentation. So that is the reason I have mentioned here. It is strongly recommended that all the areas where the foam is stored or handled to be protected by the automatic sprinkler system. So is sprinkler system what exactly give the advantage to us? The first of all, it is in case of any fire happened in the facility, the first thing that all the human beings should be accumulated to the emergency assembly point, and you don't need to do any firefighting operation. The sprinkler would allow to douse the fire from their own. There is no manual intervention is required. The second thing is that if one area is already in the fire, so sprinkler, maybe that area is already gone, where the sprinkler is operated also, but the other areas of the factory is absolutely safe. in that situation. So automatic sprinkler is always recommended where the foam is stored or handled. Passive fire protection system, we you can have the fire resistance door, you can do the fire retardant painting of the electrical cables, you can use the fire sealant, emergency exit. One of the uh, most hazard present in any industry is the electrical hazards because we cannot see inside the wire whether it is overheating or any arcing is there, anything is there. So this fire retardant point paint over your LT panel cable or your ST panel cable where the wiring is where the wire is basically moving from one area to another area. The opening can be sealed using fire sealant. So these type of risk reduction measures, if we adopted in our factory, it is it will be definitely reducing our overall risk, and we can say that okay, because of the occupancy, the hazard is same, the probability is there, absolutely there, but the severity would not be high. So insurance work into two aspects. One is probability and one is severity. The probability is this how probable is any factory in the case of for the fire incident, and one is how much severe. So in case of a fire, if it has happened, how much severe it would be, and what is the probability. The first thing is the prevention. So if you have taken the adequate prevention measures to minimize the fire, then absolutely the probability would be less. And next point is, in case of the fire happened in your premises, then what protection system you are having to minimize the severity. Okay. So we normally calculate the overall risk into probability multiply severity by visiting any factory for the risk assessment, right? So these are some of the risk reduction measures. Next is it's very important. You should have the risk inspections, risk assessments of your plant, continual risk inspections, continual risk assessments in the plant. It is always suggested that these activities should be performed by some professional who belong from the third party. The reason is this: you might have the SHE department, the EHS department, safety committees formed, everything is there, and you are doing gamba also of your plant to find out the hazards or something else, right? But somehow what is happening? No, we are seeing the similar thing into the daily basis, so that might overlook by us. So when suppose being a risk engineer, when I am visiting any particular factory, and I am going to the peer type of factory basically. So I can just suggest them so many different things because this is not there in your factory, this is there in the another factory like that. So the risk inspections plays a very important role for your loss prevention measures, fire safety audit, warehouse risk assessments, thermal imaging, thermography activity, very important. Thermal imaging, what thermal imaging will do? Thermal imaging is basically a camera, a thermography camera. Some of foam manufacturers may be having also. So it is an activity to find out the hotspot in the electrical cables, especially. So when I point the electrical camera over the electrical cable, it would give me the temperature of that particular cable, which I cannot see from my naked eyes, right? So by doing this particular activity, starting from your transformer, then ST panel, the LT panel, you can at the same time you can identify that where the problem is this. So as a prevention measures, you all these activities, electrical safety audit, comprehensive safety audit, if you are performing these type of activity in your premises uh, by the third party, by professional, that means you are making a safer environment uh, for your entire human being who are working, all the workers who are working in the facility, as well as from the entire safety and business interruption point of view. So these are the activities which plays a very important role. I will not go into very depth of each activity. Each activity is scope, objective, different. Warehouse risk assessment is only dedicatedly for warehouse. Electrical safety audit only electrical. Comprehensive safety audit scope is human plus fire. Fire is only fire. Risk inspections MCO, where M stands for management, construction, occupation, protection, and exposure. Thermal imaging is again only for your STLT panels and your transformers, right? So these are some of the loss prevention measures which every puff industry and allied protection industry should adopt, right? Now, going ahead, the insurance perspective when we are talking about, so what we understand right now, we identify the risk, we do the risk analysis, In the risk analysis, we find out that our industry is having the more hazard as comparison to other industries. Uh, we we did the risk analysis on the basis of the four parts: raw material storage, final product, finished goods, other hazards, and the process hazard. Then we find out the risk reduction measures also. Now, the another thing, what we can do, we we have done the adequate risk reduction measures. We have adopted the risk reduction measures from our end. Now, still, we are having the chance to transfer our risk to an insurance company. This is work into a similar method. I think everybody who is the part of this particular webinar aware about how insurance works. It is easy now. We are all having bike or car at our home. So we took the insurance by paying a certain amount, which is known as a premium. So we cover the entire car. So if my car or anybody's car meets with an accident or something else, the insurance company compensates the loss. This is how similarly the industrial insurance works. So what is fire insurance? Insurance is a coverage that protects a policyholder from the financial losses arising out from the insured parent damaging their property. So if your facility, if your factory, if you are taking the fire insurance of your factory, and in case of any fire happened in your plant, because of that, there are some damages happened to your building, your plant and machinery is stopped. So the value of that is basically compensated by the insurance company. So suppose you have taken the fire insurance of a factory for 100 rupees, and a fire incident got happened in your factory, and because of that you arising a loss of around 30 rupees or 40 rupees. So you would say to the insurance company that there is a fire happened in my factory. They would appoint one surveyor. Surveyor would visit to your factory. They would ask for certain documents from you about the bills and all, invoices and all, and after that the insurance company will settle the claim. Similar, right? So, for example, a factory has a property insurance policy. The factory is entirely gutted in the fire. A new factory is set up by the policy holder to replace the existing one. The cost of setting up a new factory will be paid through insurance. So I'm talking about only 100 rupees and 30 rupees. Here, the example is like entire factory is gutted. Like my 100 rupees entire factory is doused with the fire. Now I have to I have to make the factory from the root, from zero. I have to start it. So the new factory, the sum insured, the value for which I have the insurance is being done, the 100 rupees will be given by the insurance company to me, and I can start a new factory set up from the amount which will be paid through insurance. So insurance help in protecting the policyholder's financial interest. In case of the loss, the same can be recovered through insurance. So this is how the insurance works, the fire insurance works. Very simple. You are having a facility. They require the value into three segments: building, plant and machinery, and stock. Building value different, plant and machinery is different, and stock different. And after that, they would be charging certain premium amount to you for yearly. For yearly fire insurance is normally happening for the 1 year, and after 1 year it is again getting renewal, right? And by paying the premium, you can have the insurance of your plant. But sometimes insurance company needs to check whether you are adopting the good safety management practices or not, everything is good or not. So they will be sending the risk engineer to check your premises if everything is good. Absolutely, they can give the policy. If they are not able to find out, okay, something is there, they can give some recommendation to you. If you improve those recommendations, then they can give the policy to you. This is how it is happening. But in the layman language, this is works in that aspect. Now going ahead, the policy section have two sections basically. Fire section. One is material damage and one is business interruption. So, for example, the loss occurs in your plant or property due to fire or allied peril. The claim is submitted and the surveyor assesses the extent and root cause to admit the claim. The loss that is admitted is paid by the insurance company. That is for material damage. So, material damage means the damages of which uh, which can be seen by the surveyor, like for your machinery, for your building, for your stock. Now, apart from that, there is a business or loss also. Maybe you are having, maybe you would require additional 7 months or 8 months to start the factory again. So the gross profit of that time, the 8 months, suppose you are getting 100 rupees gross profit per month. And if you are not able to do the production by 9 months or 10 months, then you would be having the loss of 1,000 rupees in 10 months. So this business interruption portion will also cover the similar thing for you. So the loss occurs in the factory due to the fire and allied perils. Fire insurance claim is admitted Due to the loss, the business is not able to run at a normal capacity with reduced turnover. The loss due to the reduced turnover as well as the standing charges involved in this section would also be paid by the insurance company to you. So fire policy is having two sections. One is material damage and one is business interruption. So you would be covering, we would be covering the entire two sections of this. I think it is clearly understood to each and everyone. Now going next, there are some uh, coverages. So how fire policy works? The first of all, it covers the fire in case of fire happened to your plant. If you are having any damages, it would be compensated by an insurance company. Lighting. So what is lightning? तो बिजली कड़कता है आसमान में. So that lightning, if it is happening because of that, if there is a loss to your factory, then the claim would be compensated. Explosion, implosion, aircraft damage, right strike, malicious damage, storm, flood, inundation, impact damage by third party, road vehicles, animals, landslide, rock slide, subsidence, leakage and overflowing of storage tank, bushfire, missile testing operation, and busting of pipe leakage and sprinklers. So these are, if these 12 perils are there, 12 reasons are there for having the loss. In case of the loss happened in any of these reasons to your factory, and you got the damage, material damage, the loss would be compensated by the insurance company to you. So this is how the standard fire policy coverages works. Now going next, I think we are not getting a time to cover this risk transfer, which is a little bit vast in comparison to SFSP and IER. Before that, I would like to show you the ESFR video, which is just a minute. It's very good, maybe. So why it is important, as you can see in this video. Just give me a minute. Okay, I'm not sure why it is not running right now, but this is the video where the fire is originated uh, in this area, and the sprinklers are installed. The ESFR sprinkler installed in this area, and after certain period, after like 1 minute or 1.5 minutes, the fire is automatically extinguished by the sprinkler protection system. So no manual intervention is required, and this is practically checked using different commodity. Now, why UEP is important? Now, going to the first slide, which we have discussed here, this uncartooned expanded plastic. Why it is important as per NFPA? Because commodity wise sprinkler installation is a different thing. So if you are if I am installing the sprinkler in my factory, and if I am making the product like plastic crates, then the sprinkler installation would be different. And if I am storing foam, sprinkler installation would be different. If I am storing corrugated boxes, sprinkler installation would be different. So design and the installation of the sprinkler basically depend upon the classification of the plastic family group. So the first of all, the important thing is this. So when we are talking about a sprinkler specifically, we have to know that the polyurethane foam come into which category of the plastic family group. After that only we can go ahead with the installation and the recognition of the sprinkler installation. So that is the reason it is very useful. I'm not sure why this video is not running. It was a let me just try once again. No worries. I think we are on time also. So thank you so very much for having this webinar. My name is Mohit Darbari. This is my contact details. In case of any query, further query, anything else, you will get this presentation from IPOA. You may connect with me. Now, any question from any participant is welcome.
So there is a question in the chat box. Why
Yeah.
it is unsafe being near airport, or what does aircraft damage means?
So aircraft damage means that suppose if any flight is moving towards if your factory is located near to the airport or near to the takeaway or flyaway zone, then there is a chances that aircraft might hit the factory. Some of the cases not happen in India, but worldwide it has happened that that the aircraft directly having the impact with the factory. So in that situation, what would occur when the flight is directly having some collision with your factory? Then there will be the fire in that situation. So that loss will also be compensated by an insurance company.
Okay. So the session is open for discussion. If you have any other questions, please ask. You can ask now.
Yes, please.
I just want to add some more points, if you just allow me.
Yes, please.
For safety factor, when we are discussing over here also, so I've just put it out 5-6 points. The number one is, am I audible?
Yes, yes.
Yes, sir, you are.
Okay. So first one is, when the fire takes place, so excavation should be first action in the industry, not to extinguish. Excavation should be first action to be taken, right? The second one is,
So you mean to say evacuation?
yes, evacuation.
Yeah.
Evacuations of the material. The fire should not spread instead of wasting time for extinguishes, right?
Right.
Second one is, more vital point is, earthing should be taken care of
Yes.
in the plant. It will not cause static charges.
Yes.
The third one is, we should have good relations with neighbors also. Not only just knowing them what they are doing, but we should have good relations also. In case of fire, we are just next to their boundaries, so they can help us to give some fire system of power or water supply and all, so that we can extinguish the fire on time also, easily.
Yes. Yes.
So we should have good relations with neighbors also.
Yes.
The fourth one is, when we construct an industry of PU foam, I'm just talking about PU foam. I belong to PU foam industry, right?
Yes.
So the wall, at least they should be at least of 12 feet high for every unit.
Yes.
So when the fire takes in in a particular unit, it will not transfer the heat or spread the fire across a wall of 9 inches and 12 feet height. That is the major concern should be there.
Hmm.
Now, as per the chemical I'm talking about, if TDI drum is punctured while unloading and something else like this, so it should be first inspected and should be unloaded first, not just keeping lying. We will take action later on.
Yes.
So first action should be taken on that drum also, if it is punctured. And the last one is, mock drills should be taken care of once in a month, at least once in a month. So everybody should know when fire exists, when it occurs, so where you have to gather, how you have to take the action, which kind of fire is there. So everybody should know, should be aware of that practice. So mock drills are very necessary in the units for PU foam at least. So these were some points what I have to add in this session.
I agreed with you, Mr. Nitin Tyagi. I think all the points are very much accurate. So whatever discussion we had, and Mr. Nitin has added on all these points, I think all these things can be achieved by having the good risk management practices and having the risk assessment activity to your plant. The first, if you are having the risk assessment, the continual risk assessment activity, that will definitely give you the aspect how you can minimize and improve the overall safety management of your facility. Uh, The third party eye, the third person who are coming to your industry is always seeing your factory from the layman point of view. He might be suggesting something to you which is not, which sometimes give you the financials uh, uh, aspect also. Maybe some recommendations are related which is difficult to implement because of practical problems, because of some financial glitches. But it would always help you to identify the risky areas in your facility, because the construction, the layout, the spreadness, uh, uh, this is different from each and every puff industry. I cannot compare any one industries to any other industry like that. Something is one facility is located in the northern region, one is in the southern region, one is the west region. Maybe you are having the 1 lakh square feet of area, the another one is not having that much of area. Your class of construction is maybe GI sheet roofing, which is prefabricated on the truss. As Nitin said, right? Maybe you are not having RCC reinforced concrete cement with brick masonry walls. So if these type of construction is not there, how to minimize? So that can be only verified by physically inspecting the risk. Once we inspect the risk physically, we identify more and more how to recognize. So risk inspections, risk evaluation, these are the phase one activity which is being performed by the professionals. And it is always recommended that in the puff industry, these activities should be performed on continual basis. This is my suggestion. So thank you, Snehalata ma'am, for arranging all these things. In case of any further question, we have a time at least 2-3 minutes. You can ask me.
Yes, so
Sir,
are there any more
I
questions?
just want one thing. Sir, the word was excavation only, not evacuation.
Sorry.
The word which I used, it was excavation, not evacuation.
Okay. So excavation, I don't understand the relevance in
Excavation
that.
means if you have nearby blocks, if I say 2-3 blocks are lying to each next to each other, na? And if a single block takes place, so instead of working on that block, we should remove all the blocks from that side.
Oh,
Need not to waste time on that particular block which has taken fire.
right. Yeah,
It
understood.
was that excavation means, na sir?
Yeah, no.
So it was not evacuation, it was excavation, please.
Absolutely, yes. Yes, Snehalata ma'am, your turn.
Yeah, so in the chat box, I don't see any more questions. So if there are no more questions, let us thank Mr. Darbari. Sir, thank you so much for
Thank
your
you very
time
much.
and the
Thank you, ma'am.
insightful presentation.
Thank you, everyone.
Sorry for Tarwari sir. I want to talk to you. सुशील मिश्रा इन कालम
हाँ सुशील जी क्या हाल चाल बताइए
सर बहुत बढ़िया सर थैंक यू वेरी थैंक्स सर एवन यू विल कम इन द कालम
एब्सोल्युटली हम दोबारा से एक बार मिलेंगे आपसे आके
हमारा कैसा लगा सर आपको
बहुत बढ़िया बहुत अच्छा दोबारा आपसे मुलाकात हुई इसी बात
हमारी ऑडिट कैसी थी सर थोड़ा बहुत
बहुत
बता दें सर
बहुत अच्छा सुशील जी बहुत बढ़िया
लेकिन आपने क्रूशियल की थी क्रूशियल नहीं बोलते सर लिटिल
हाँ
बिट को भी नहीं छोड़ा आपने मैं आपकी मैं आपकी ऑडिट को बहुत ज्यादा अप्रिशिएट करता हूँ आपने जो है
थैंक यू
सर तिवारी सर के बाद जो है मैं आपको नंबर देता हूँ क्योंकि आपने मतलब बिल्कुल मार्जिन हमें दिया ही नहीं है सर
थैंक यू सुशील जी आपके जैसे लोग होते हैं जो इम्प्लीमेंट करते हैं तो हम लोग को भी फाइंड आउट करने में ऑब्जर्व करने में मजा आता है चीजें हम भी चाहते हैं कि हमारे जितने भी क्लाइंट हैं हमसे जुड़े हैं ये पूरी इंडस्ट्री जो है ये लॉसेस से सेफ रहे क्योंकि लॉसेस आना बड़ी बात नहीं होती है उस बिजनेस को दोबारा से फिर उस मोमेंट पे पहुंचा पाना बहुत ज्यादा मुश्किल हो जाता है आजकल के जमाने में
नहीं ये मैं भी कहूंगा दरबारी सर मैं भी कहूंगा मैं ग्रेटर नोएडा विनोद कुमार द्विवेदी विनोद द्विवेदी फ्रॉम ग्रेटर नोएडा नमस्ते साहब बहुत अच्छा था आपके साथ ऑडिट करने का और मैं समझता हूँ जो प्रेजेंटेशन में आपने दिखाया है शायद सभी चीजें मैं अपने यहाँ इम्प्लीमेंटेड हमारे ग्रेटर नोएडा प्लांट में है
बिल्कुल
और जो आपने कभी सजेस्ट भी किया था मैंने कई चीजों को इम्प्लीमेंट किया तो वेरी गुड सर आपका ऑडिट था बहुत अच्छा, और यहाँ भी मुझे बहुत अच्छा लगा जो आपने यहाँ पर प्रेजेंटेशन किया।
बहुत
Thank you,
बहुत
sir.
धन्यवाद सर, बहुत बहुत धन्यवाद।
बस है ना सर, ये तिवारी सर तो हमारे थोड़ा बहुत रिलैक्सेशन दे देते हैं हमें, और उनकी जो ऑडिट है उनको तो अप्रिशिएट करते ही करता हूँ, मेरे बॉस है। बट आपको थोड़ा इसलिए मतलब जो है कि आपने बिल्कुल रिलैक्सेशन दिया नहीं, एकदम छोटी छोटी चीजों में मुझे छूटे नहीं, मेरे को डांटते रहे, और मैंने और बेहतर कर लिया है सर।
बहुत
अभी
बहुत
एक बार
धन्यवाद।
और दीजिए चांस सर।
बिल्कुल
थैंक यू
आएंगे
सर,
सर, बिल्कुल आएंगे, हाँ बिल्कुल
थैंक
आएंगे।
यू सर,
थैंक यू सो
थैंक
मच,
यू आपका।
thank you Snehata ma'am, thank you ITU entire team for arranging this particular session among all the participants. Thank you once again.
Thank you, Mohit ji. Thank you. Thank you, everyone.
Thank you.